Hey everybody, sorry for the delay in getting this up. I had some technology and Wi-Fi issues, but I'm all set now. I'm going to be recapping what we were working on Friday with rectangles. So some of these notes will overlap, and then it will go into that little bit we missed at the end. I am out on Tuesday and Wednesday, so Tuesday evening you need to check back here for the next set of notes, so you'll be able to do the work in class on Wednesday. So again, we are talking about rectangles. Okay, so just recapping our first bit on our notes, we said what is a rectangle? And we said it is a special type of parallelogram where the opposite angles are congruent, the opposite sides are parallel and congruent, and we said that the consecutive angles are supplementary. And the other thing that I've got to get in here is we also said that the diagonals bisect. Now, all of those are also true of parallelograms. So those four conditions have to be met for it to be a parallelogram. And then we have to meet two additional conditions for it to be the special type of parallelogram that is a rectangle. So the special cases that we are looking at, we need to say that it has 4 right angles. And we also know that the diagonals are congruent. So before we said they just bisect, but now we are also saying that they are congruent. So if we have a rectangle in here, if it's bisected, this is congruent to this by bisection. But because this whole diagonal from here to here has to match this diagonal from here to here, that means these pieces will also match. So all 4 halves of the diagonals are congruent. So in our next bit, we were asking ourselves, how can we prove if a figure is a rectangle? And we said that we've got 2 possibilities that we can approach it with. So we had the givens that we had a quadrilateral PQRS with the points at -5, 3. I'm sorry this is sloppy, I'm just writing with a finger and small screen. 1, -1, -1, -4, and the 4th point at -7, 0. And we made a quick sketch on a coordinate plane in our notes, and we ended up with something along the lines of that. That should be right there on the y-axis, the x-axis. So we had PQRS. So that's what would happen if we had actually put it into sketch. So we said we could look at this and do the distance formula. We need to prove that the opposite sides are congruent. So through the distance formula, we can seek to prove that PQ is congruent to SR and prove that PS is congruent to QR. And we would do that, of course, by plugging in the coordinates. So you'd take P and Q, find their coordinates up here, which is be this first 2 set, and plug into the distance formula. So -5 minus 1 quantity squared plus 3 minus -1 quantity squared, something along those lines would work. We'd end up with PQ at the square root of 52. Plugging in the coordinates for S and R, we'd also get SR to the square root of 52. They're equal, therefore they're congruent. And in PS, if we plug in our coordinates, we get square root of 13. And in QR, we also get the square root of 13. So by doing that, we've proved that our quadrilateral is actually a parallelogram because the opposite sides are congruent, which is one of the conditions of the parallelogram. Now we need to prove that it's actually a rectangle, the special type of parallelogram. So to prove that, we need to prove about those 2 diagonals. So we need to now prove that PR is congruent to the diagonal SQ. So again, we're just going to take those coordinates that we had, and you're using distance formula. So find your P, find your R, and plug into your difference of your X values, quantity squared, plus difference of Y values, quantity squared, take the square root. And if you need distance formula, look back in your notes for it. But PR would be the square root of 65, and SQ is also the square root of 65. So since I've proven opposite sides congruent and diagonals congruent, now I have proven it's a rectangle. So that proves that it is a rectangle. Squish that in there. But you don't have to prove it just through the sides and using that. We could also have chosen to prove by slope. So if we want to prove by slope, if we prove that the opposite sides have the same slope, then we will know that it is a parallelogram. So if we can prove the two longer sides have the same slope and the two shorter sides have the same slope, then we have proven that the opposite sides are parallel. Then if I prove that the consecutive sides have perpendicular slopes, remember perpendicular slopes, you're looking for the opposite reciprocal. So if you have 1/2, the opposite would be -2 or -2/1. So if you prove they have opposite reciprocal slopes, if that's a yes, then we know we have a right angle. And we know that is part of a definition of a rectangle, that we have 4 right angles. So if I went back the screen where we were looking at, where we have our coordinates, we could be plugging into the slope formula. So using the y sub 2 minus y sub 1 over x sub 2 minus x sub 1, and we can find the slopes for all the sides. We're looking for the opposite sides to have matching slopes to prove parallel. And then we're looking for the two sides where they come together to have those opposite reciprocals to prove that we have a right angle. So if we prove that we have a parallelogram and we prove we have right angles, then we know we have a rectangle. All right, so for classwork in class, you're working in your workbook on page 78 and following those directions throughout. So in the first 6, you're just using algebra, using the conditions of a rectangle to know which things need to be equal to each other, etc. And then in your 7 to 12, they're giving you an angle you're plugging in. And then when you get into that 13, 14, 15, they're asking you to graph each quadrilateral with the given vertices, determine whether the figure is a rectangle, and justify the answer using the indicated formula. So if you're working on number 13, you need to find all the slopes of all the sides that you've graphed. And you can do that through your slope formula. If it's on the graph, you can count rise over run. In number 14, they're asking you to do it by distance formula. So yes, you need to find the distances of each of the 4 sides and also the distances of the 2 diagonals. All right, so that's what you're working on in class. If you finish it during class time, you can go back and work on workbook page 77 for some extra credits if you would like to do so. And then check back in here tomorrow evening for your notes to move on to the next. So the way we're going to do this is you do your notes at home as homework, and then you will have your classwork to work on in class. And I will be back on Thursday with y'all.